All right, section 9.6 is on the ratio test. So we're going to get series like this that are comparing different things. We have an exponential and a polynomial taking on a factorial. Now we know factorial can beat them individually, but if they team up, is that enough to overpower the factorial, or will the factorial eventually win? Now you can put this on your calculator and extend the ends out. And what you will see is that over time, this does go to 0, okay, as a sequence. So the factorial will eventually beat those two to even together as a sequence, but that still doesn't tell us, if we add up those terms, if that's enough to make the sum of the terms converge or if they're gonna blow up. So at this point, we really don't know about this. We would need a little bit of help, all right? So the help comes in what's called the ratio test. The ratio test says that if we have a series with non-zero terms, so just a nice positive, well, it doesn't even have to be positive, just a series, okay? Then we are going to do this structure here. So you'll see this is consistent in all three of them. What we're gonna do is we're going to put a ratio of the next term divided by the previous term. So we're gonna take our general term and we're gonna say what would have been, the general term will go on the bottom, so the previous term will be our general term. And we'll say, what would be the next term in the general term? In other words, we're going to add 1 to all the ends, all right? And that'll be what our next term is. And then we're going to take that ratio and we're going to let n go to infinity. And the question we're really asking ourselves is there a significant difference between those terms as n gets bigger and bigger and bigger? Is there a significant gap between them? If that gap, if the previous term is significantly bigger than the next term, which means our terms would be getting smaller and smaller significantly, then this ratio will be less than 1. And if that's the case, then our series will converge absolutely. The terms are getting significantly smaller, therefore the sum is staying contained. If for some reason, though, the next term is significantly bigger than the previous term, then this limit would be greater than 1. Our series will diverge, okay? Now this is going to be used in cases where maybe we aren't sure about the sequence. We aren't sure what the sequence does. Like the nth term test would have probably gotten rid of some of them, but if you're not sure, this is what we would use there. And if we put them together and we do this and we get 1, what that means is that there's no significant difference between one term and the next. And unfortunately, that just means the ratio test doesn't tell us. Maybe it converges, maybe it diverges, but the ratio test wasn't what you should have used for it. So again, the ratio test is really helpful when we're doing factorials and maybe some combinations of things. So right here we have factorial over exponential. We're pretty sure this diverges because we're pretty sure factorial beats exponential. But let's go ahead and prove it. So we're going to take the limit as n approaches infinity of, and then we're going to put this general term on the bottom. And then we're going to say, what would have been the next term? The next term from n factorial would be n plus 1 factorial. We're going to add 1 to that n. The next term for 2 to the n would be 2 to the n plus 1. Okay? And so then we're going to go ahead and flip that. And we're going to have n plus 1 factorial over n factorial times 2 to the n over 2 to the n plus 1. So again, I'm flipping it and kind of reorganizing it so that things are set up. What that's going to give us then is the limit as n approaches infinity of this, which would be n plus 1, over this, which is 2. Okay, if we let n get bigger and bigger and bigger, what does this go to? This goes to infinity. Okay? So we did our ratio test, and we got infinity. That's bigger than 1. So therefore, the series diverges by ratio test. Let's try another one. Got this one here. Okay, again, we have factorial over under exponential, so we're pretty sure this sequence goes to 0. Maybe that would lead us to believe this should converge, right? We're kind of feeling that, but let's do the ratio test to prove it. So we're going to take the limit as n goes to infinity of, and then we'll put 10 to the n over n plus 1 factorial on the bottom. And on the top, we'll have 10 to the n plus 1 over n plus 2 factorial on the top, okay? If we do some flipping, we're going to get n plus 1 factorial over n plus 2 factorial. And then we're going to get 10 to the n plus 1 over 10 to the n. All right. On the top will be that extra 10. And on the bottom will be this n plus 2. So if we let n get bigger and bigger and bigger, this is going to go to 0. All right, well, 0 is less than 1, so our series converges, and we know it converges absolutely. Which we didn't have an alternator anyway, so. But if you had an alternator on there, this just tells you that the alternator didn't have to be there, okay? All right, let's apply it on this one. So we're going to take the limit as n goes to infinity of, put this on the bottom, 3 to the n over n cubed, and on the top we'll have 3 to the n plus 1 over n plus 1 cubed. All right, it gives us limit as n approaches infinity of 3 to the n plus 1 over 3 to the n, and then n cubed over n plus 1 cubed. All right, now this is going to give us 3, right? And then this is going to have n cubed over n cubed, and if we let n go to infinity, this part will equal 1. So we're going to get 3 times 1, or 3. Okay, that's greater than 0, so this series diverges. And we would have guessed that, right? It's an exponential over a polynomial. Exponential is going to beat polynomial. Diverges is exactly what we would have expected. Okay. Now, again, if you pick the ratio test for something that's not appropriate, like this we already know converges, right? But if I do ratio test on it, just real quick to show you what happens, we're going to get 1 over n squared here, 1 over n plus 1 squared here, which leads us to the limit as n approaches infinity of n squared over n plus 1 squared, which equals 1. Inconclusive, right? That function that series may or may not converge. We know this one converges, but then if we had done it on the harmonic series, which diverges, you would have ended up with the same conclusion. We would have had 1 over n plus 1 over 1 over n, which gives us, sorry that I'm rushing here. So here's a divergent series that gives us 1. Here's a convergent series that gives us 1. The 1 doesn't necessarily tell you. What it just tells you is that both of these series, the terms that are coming are not significantly more or less than the term before it. And so the ratio test can't help us. And so don't come up with a conclusion off the 1. It just means that there was a previous test that you probably should have used.